Hello, my name is Patrick McGuire. I'm a visiting scholar for Reasons to Believe, and today I'm going to give you a tour of the geology of a formation called Sentinel Rock in the Garden of the Gods in Colorado Springs, Colorado. And we're basically going to look at this as a geologist. I'm not a professional geologist, but I do a lot of work with sedimentary rocks, and that's what the Garden of the Gods is all about. We're going to be looking at multiple depositional environments. We have a system called fluvial, which is a fancy geological word. It just means rivers and streams. We have another depositional system. It's called aeolian, which again is a fancy word. It means windblown. So think of a sandstorm. And then we have shallow marine depositional systems, and we're going to be looking at a limestone deposit. And at the Garden of the Gods, we see all of these different kinds of depositional systems, and they go back and forth, back and forth. So it's fairly complex. And then there's a lot of structural complexity, and you're going to see that when I start showing pictures. These formations were cemented into solid rock. There was a lot of faulting. The whole thing was uplifted and tilted to where now a lot of the rocks are going straight up into the sky. And then there has been a very long time of erosion, which leaves some really beautiful rock formations. And this is one of these rock formations at the Garden of the Gods. This is the Keyhole in the Siamese Twins. And behind the Keyhole and my beautiful wife and little doggy is Pikes Peak. So it's a very scenic area. One of the things I'm going to encourage people to do is when you go to visit one of these wonderful scenic places throughout the United States, but especially in the West, is to do a little bit of homework on your geology so that you can appreciate what's there. Because quite often you will enjoy it a lot more if you're actually able to see and understand what it is you're looking at. And this is the Keyhole. My daughter actually is in the Keyhole, and that's the formation called the Siamese Twins. And this is it's the Fountain Formation, which is Pennsylvanian age. That's about 300 million years old, and it's flat-lying fluvial rock, which basically means it was laid down flat, and it's still more or less flat. And fluvial again is rivers and streams. Now, the real reason people go visit Garden of the Gods, and it's one of the most visited spots in all of Colorado, is not the flat-lying fluvial stuff, but we're looking here at rocks that are tilted straight up, so they're pointing to outer space. And this is the Lyons Formation. And these are aeolian rocks, which basically means these are fossilized, deep desert sand dunes. So think of the biggest sand dune you've ever seen a picture of in the Sahara Desert. Well, that's what happened about 280 million years ago. The sand dunes were laid down, and then Pikes Peak was thrust up and turned these rocks over to now where they're facing straight up into the sky. And about 300 billion years ago, when all this happened, the United States was part of the supercontinent called Pangaea. So this is what the world looked like 300 million years ago, and you can see all of the continents were lumped together, and the red arrow, that's showing where the Garden of the Gods is. It's right about there, right in the middle of the North American continent, which is part of a much bigger continent at this point in time. And when you go to somebody's national park, what I would encourage you to do if you can, go on the internet or maybe stop at a visitor center and see if you can get what's called a Geologic Outcrop Map. And that's what I have here for Garden of the Gods. And that little yellow circle in the center, that's the place where we're going to be spending our time, and I'll be showing you pictures. And that's basically where the rocks are sticking straight up in the air. And you can see the color there, that little gray color, that's the Lyons sandstone. The purple, that's the Pennsylvanian age fountain formation. And so you've got this standing straight up into the sky sandstone, and then you've got this fountain formation right next to it that's essentially horizontal. So that's why there's a whole lot more purple, and the rest of these guys are stripes. And this is what happened about 65 million years ago, about just before the comet hit and killed all the dinosaurs. We had these flat-lying sediments that were eroded from the ancestral Rocky Mountains and laid down flat, and then the modern Rocky Mountains were uplifted, and they turned these sediments to going straight up. So what you've got here is if you look at my arrow, there's what's called the Rampart Range Fault. So this fault was upthrust, and it turned the sediments partially vertical. And then you had the second fault, the Youthpass Fault, which rose many thousands of feet in the air and made Pikes Peak, and that caused the whole thing to go straight up. And then millions of years of erosion, and that's basically what we're left with now, is these peaks that are sticking straight up into the air, and then this flat-lying maroon sediment. That's where the Siamese Twins are. So what did this look like when these sediments were laid down? Well, Pangaea was not a nice place. To put it mildly, it was not a nice place. You can read here, basically the inland areas were dominated by vast swaths of desert, while the shallow seas were surrounded humid swamp forests. So right around the edge of this gigantic supercontinent, it was wet and hot and humid, but you get inland any distance at all, and it formed these really nasty deserts. And this is probably the biggest desert that has ever existed on planet Earth. And while this Permian era is known for several things, predominantly it's known for this kind of really gross, barren desert. And as I mentioned earlier, I call it the desert from hell. But especially in the late Permian, this turned into this sun-bleached desert, and it was starved of water, hostile, scorched earth landscape, the biggest desert the world has ever known. And what's really interesting, the nights were bitterly cold while the days were blasted by the intense heat of the sun, rather like modern deserts, yet far more intense. So this was so dry and so far from the ocean, and just no moisture at all, so there's nothing to hold in the heat. It's cold at night, bitterly cold, and brutally hot in the day. So it's serious desert countryside. Now, the geologic formation we want to look at that was laid down during this time frame is what's called Sentinel Rock. And you can see in this particular picture this red sandstone here, and this is one of the deep desert deposits that's been turned over on its side. This white stuff here, that's actually a river channel. It contains a formation called a conglomerate. So they're right next to each other, but one is done by flowing water, the other is done by blowing wind. So I went out last week and took some pictures of this so I could do this presentation. And so here's my picture of Sentinel Rock. Again, here's the deep desert deposits, the stuff in red. And then this grayish looking stuff here, we're going to get up close and personal, and we're going to see that these are actually conglomeratic. They're laid down by a very substantial and fast-flowing river. And then the area I'm going to show you pictures of now is right here. And I've turned it over. The sediments are like this now. That's not how they were laid down, so I'm going to put them back flat. So you can see my tree that is no longer vertical, it is sideways. And now you can see this river system that was flowing on top of this deep desert sands, the fossilized sand dunes. And we're going to get a little more close up and personal, but you can see there's lots of big undulations in this surface. So this rapidly flowing water just ate big gouges out of this big sand dune that was fossilized. It wasn't fossilized at the time. So we're going to get a little closer. And it's unless you have something for scale, it's hard to see how big these grains are. So that's why my finger is in this picture. So I'm doing this and trying to take a picture with one hand. I'm not very good at it, but it worked. And so you can see how big these grains are. And if you have sand grains that are this big, a big chunk of the size of your fingernail, that means you've got very high energy water. This is not a slow moving river. This thing is, the way I think of it is, think of Arizona deserts in a big thunderstorm, and you get a dump of rain, and then all this water carrying all this sediment comes down an arroyo or a old dry riverbed. Well, that's what's going on here. A lot of energy, there's a lot of sediment. So this actually is sediment from the ancient Rocky Mountains that's being washed out into this river system. And this is a picture. I'm explaining all of this stuff to a friend of mine who's actually from California, just up in the Central Valley. And this was his first trip to Colorado, so I'm showing him the boundary between the sand sediments here, the Aeolian deep desert sandstones, from the conglomerates that are laid down by flowing water. And then here is a close-up of it. So again, it's very easy to tell the difference between these windborne sediments and the waterborne sediments. And you notice you don't see any layering or lamination or anything in the windblown, the Aeolian sediments. But it's real easy to see the stratification in the waterborne sediments, and you can actually see it's straight line, but you've gouged out little areas because the water's going fast. So this is, a geologist would call this an unconformity. Basically, the sediments that are being laid down now are eroding into the sediments that were laid down before. And again, this takes a fair amount of energy to dig these kind of gouges. One of the things that I found really interesting, and I had no idea this was out here until I started looking, is there are some of the most beautiful, what are called inner-fingered deposits that I've ever seen. And basically, inner-fingered is like this. You've got different kinds of sedimentary rock that it looks just like you're lacing your fingers together. And we're going to get a little closer inside the yellow box and take a look at these. And I'm going to start right here. And that is this particular picture. And again, you can see this red wind-blown sand where the sand is actually starting to engulf the river system here. You've got these giant dunes that are actually starting to choke the river. So you've got a big pulse of wind-blown sand between two, let's call them summer thunderstorms, that lay down all this conglomeratic rock. And that's neat, but I think this next picture is neater. Let me go back, and I'm going to show you this part right here. And that is this inner fingering. And what you can see is pulses of waterborne conglomeratic rock, and you can see pulses of sand coming from these deep desert sand dunes. So you've got this mixture, and they're just kind of inner-fingered. This is probably one of the best examples I've ever seen of an inner-fingered deposit. And eventually, the sand dunes completely overwhelmed this river system. And that's why, let's go back a few slides. That's why you get all of this rock here. There's no water in any of this. It's just completely deep desert sand dunes. And it's hundreds of feet thick when it was laid down. It's hundreds of feet sideways now, but it was hundreds of feet thick of sand dunes that were laid down in the Lyons Sandstone Formation. And there's no water at all, no interfingering, it's just all dunes. And then now we're going to walk along this pathway, and we're going to go behind the Lyons Formation, Lyons, and we're going to see the Lycans Limestone. So walk down the path. There's maybe 50 yards between this vertical sandstone and this vertical limestone. And it's just kind of a drab, grayish white color, and you get up close to it, and that's what it looks like. It looks absolutely nothing like a sandstone or a conglomerate. It's just blah. There's probably a better geologic word than blah, but that's what I use. This limestone was laid down in shallow water, and it's salt water. And this is during the Triassic period, which is the first period of the dinosaurs. So this is about maybe 200 million years ago. And this limestone was compressed and heated up as it was buried, and a little bit of it dissolved, and it just, whatever structure it had, it just went away, and then the limestone precipitated out. So it's just one kind of solid mass. But you can see the little cracks where some of the dissolved limestone reprecipitated. It's the same chemically, but that's about the only structure it has, is kind of limestone cement filling in these little cracks. And one of the clues, if you're looking at a really boring rock, if you know it's sedimentary rock but it's really boring, that's likely limestone. Sandstones tend to be really interesting. So, as a summary of what we just went through, as amateur geologists looking at some really beautiful scenery but trying to put a little science into it, we've looked at multiple depositional environments. We have fluvial, which again is rivers and streams, and that's the river that was flowing like during these monsoon storms and laying down the conglomerates. We have aeolian deposits, which are big sand dunes that eventually completely overwhelmed this river system. And then we have, on top of that, when Pangea split and Europe and North America separated from the rest of the continents, we actually had water come in, seawater, shallow water, and then we had all the limestone reefs, corals, those kind of critters that lay down limestone systems. They laid down the boring Lycans Formation. And these things, they alternated back and forth, especially like you could see in the interfingered deposits that I showed you. And then we had the structural complexity, because all of this stuff had to be turned into solid rock. And then the Rampart Fault came through and partially overturned these formations. And then the Youthpass Fault came, and that's what turned these deposits from pointing sideways to pointing out into space. So there's a lot of complexity that's gone on here, and this all took a very, very long time to do, tens of millions of years. And the kind of key point from an apologetics point of view here is that none of these deposits were deep water deposits. They were either freshwater or deep desert deposits or shallow marine, but none of this was laid down in fresh and deep water, and none of this came from Noah's flood. This all happened over a very long period of time, and very different depositional systems. And one of the things I'd like to encourage people to do is next time you go to someplace like Zion National Park or Bryce Canyon or Canyonlands or Arches, is do a little digging on the internet to get some of this kind of geological information before you go. And then have an eye to see, well, what can I pick up as I'm looking at all this beautiful scenery, and get up close and personal to some of it. And I think you'll find that there's a lot you can learn as an amateur, but with a little information.